Okay, so now we're going to start applying the concept of tau equals I alpha to problems. Okay, let's take a look at a simple problem first. Let's say that I have a pulley of some radius r, and let the moment of inertia of the pulley be I. Okay, if it's a solid disk, we can take 1/2 mr square. If it's something else, we could figure out the moment of inertia of this object. Let us say that we wrap a string around this object and we pull onto the string with some force F. Okay, and our question is, what is the moment of inertia of what is the angular acceleration of the pulley? Okay, as it's being pulled. We're going to assume that the string does not slip on the pulley. It's basically going to cause the pulley to rotate. Okay. So here we're very simply going to use tau equals I alpha. Okay, as we do these things, just remember, whenever you're given a problem, always ask yourself, like, what concept can I use? Most of the times when we're looking for alpha or acceleration, you're going to use either Newton's second law, you're going to use F equals or tau equals I alpha, or some ideas like that. Okay, it's not too many options. If we're looking for speeds, angular speeds, most of the times you're going to use concepts of energy or momentum or something. Okay, so these problems hopefully will make all that clear. Alright, so in this case we know that the torque is due to this force F. Okay, so tau we know is equal to R times F times sine of 90. Okay, but we know that tau is also equal to I times alpha. So therefore, we end up getting alpha is equal to R times F over I. So very simple problem. Okay. However, understand the process of what happened here, and so simply by using tau equals I alpha, we end up with the angular acceleration. Now, if let's say instead of just asking for the angular acceleration, I also asked you for the acceleration of any point on the outside, on the surface of this disk. Okay, like the outermost part of the disk. What would the acceleration of that point be? Okay, the relationship between the acceleration and the angular acceleration is very simple. It is simply equal to R times alpha, and so we can multiply it by this, and we end up getting R square F divided by I. Okay, so this relationship also is very important. It's going to keep coming up. Just remember this, that if whenever something is turning around, okay, then the acceleration, and by acceleration here we mean the tangential acceleration, okay, of any point on the circle is related to the angular acceleration, okay, by this relationship. Like 8 sub t we know is equal to R times alpha. Okay, so keep this in mind, and everything should be good.